Hello everyone. Today we're going to go over voltaic cells in chapter 21.1. So, what is a voltaic cell? A voltaic cell is essentially a redox reaction with, instead of it going directly, it has some sort of wire or connecting device which the electrons go through, which produces a current. So, how do you make a voltaic cell? Well, first off, you need two materials in two, preferably metals, in an aqueous solution, and they need to be different. In this, we are going to use the example of a zinc strip and a copper strip. So, what happens? Well, we're going to say the zinc is going to be negative, is going to be just plain old zinc, and the copper is just going to be plain old copper. So, what happens? There happens an electron flow between the two. And in this electron flow, it goes from positive to negative. So, in this example, it would go from zinc to copper. So, we got that down. The electrons transfer from zinc and flow over to copper. But, what else do we need? Well, what we notice is that there's a buildup of positive ions in the zinc side and negative ions in the salt side. So what do we need to do to fix that? Well, what we can do is we can use something called a salt bridge. And this will contain some sort of salt. In this example, we're going to use sodium and chlorine. And then this will balance it out, essentially. So it won't be negative or positive on either side, because if it was negative on one side and positive on the other, it would not react. And what we're really doing is something called a redox reaction, except we're having it in two separate containers, which makes the battery. So, next we're going to talk about half cells. Anodes and cathodes. What is an anode? An anode is where the oxidation takes place in the redox reaction. So in our example, it would be the zinc. And this would be the anode side. It would give off the electrical current, and it would flow. This would be the side it's flowing from. Next this is called one of the half cells. The cathode in our example would be the copper. And the copper would then flow over this would be the reduction. And the reduction would be gaining the electrons. So, what else do we need to know? This entire system is yet again called a voltaic cell. And how would we make it? Well, first off, we'd have the two strips in each side, and then when they're in each side, the zinc and copper in an aqueous solution, we then put in the salt bridge, and the salt bridge would not allow anything to go through it besides our sodium and our chlorine to balance it out. And one of the first ones is called a voltaic pile, made by Alessandro Volta. And what he did was he stacked a whole bunch of copper and zinc, I can't remember what it was, and had cloth in between each with salt in it, and this was the creator of the first voltaic cell, which is now called a battery. Remember this term. So, how do we calculate the electrochemical cell potential? We call the tendency of a substance to gain electrons its reduction potential. So, we would put this in an equation later on. So, what is the standard for the reduction potential? Well, the standard is called standard hydrogen electrolyte, and it consists of a small platinum sheet immersed in HCl that has a hydrogen ion concentration of 1 molarity, a hydrogen gas at a pressure of 1 atm is bubbled in, and the temperature is maintained at 25 Celsius, and it's with a platinum electrolyte. And then we can use that to calculate the voltaic potential. If it's negative, it would go towards the H plus, and if it's positive, it would go away from the hydrogen. So, what would be the equation? Well, we would first do the oxidation, and how we'd write that is H2 line H plus double line Cu2 plus line Cu, and the second part is the reduction half cell. The first part is the oxidation half cell. So that's what we would use there, and then we would plug it into the equation of EO cell equals EO reduction minus EO oxidation. And you may be asking, how do we get those numbers? Well, you actually have a sheet which you have to take those off of. So then we can use this to calculate whether it would be spontaneous or non-spontaneous. Positive numbers would be spontaneous, negative numbers non-spontaneous. You need electricity to make that happen. And that is it for 21.1.